What causes slope failures? When a hillside suddenly gives way or a road on an embankment collapses, it's not just nature acting randomly. These are signs of slope failure, and behind every failure lies a story of hidden forces, unstable soils, and engineering oversights. In this video, let's break down the causes of slope failures and how geotechnical engineers work to prevent them. Understanding slope failure. Slope failure is the movement of soil, rock, or debris down a slope due to gravity. It can occur gradually or suddenly, and its consequences can range from minor erosion to catastrophic landslides that endanger lives and infrastructure. Engineers analyze slopes to determine their stability, a balance between driving forces like gravity and resisting forces like soil strength. When that balance is tipped, failure occurs. Natural causes of slope failures. First, let's explore the natural causes. These are the most common triggers in hilly or mountainous regions. Heavy rainfall, one of the leading causes of slope failure. When water infiltrates the soil, it increases pore water pressure, reducing soil strength and increasing the weight of the slope. This makes slopes more prone to sliding. Earthquakes. Ground shaking during earthquakes can disturb the balance of forces on a slope, especially in loose or saturated soils. This can trigger landslides and soil liquefaction. A weathering. Over time, rocks and soils break down due to chemical, physical, and biological processes. Weathered materials lose their cohesion and are more likely to fail. Vegetation loss. Trees and plants play a critical role in slope stability. Their roots bind the soil, and their canopy reduces rain impact. Removing vegetation for construction or agriculture can destabilize slopes. Human-induced causes. Many slope failures are actually caused or worsened by human activities. Improper excavation. Cutting into slopes without proper retaining structures or slope angles can remove crucial support and cause collapse. Overloading the crest. Adding weight at the top of a slope, like buildings, vehicles, or stockpiles, adds extra stress and can lead to failure, especially in soft soils. Poor drainage. Inadequate drainage allows water to accumulate in the soil, increasing pore pressure and reducing shear strength. This is often seen in road and railway embankments. Mining and quarrying. These activities often disrupt the natural structure of slopes and remove supportive materials, making the remaining soil more vulnerable to sliding. Types of slope failures. Not all slope failures look the same. They can be classified based on how the material moves. Rotational slides. These occur along a curved surface and are common in cohesive soils like clay. They create a bowl-like depression at the top. Translational slides. These move along a flat surface, often in layered soils or rocks, and are faster and more dangerous. Flows. When saturated soil behaves like a liquid and flows down the slope, it becomes a debris flow or mudslide. These are rapid and destructive. Topples and falls. In steep rocky terrain, large blocks can detach and fall due to gravity and cracks in the rock mass. Signs of potential failure. Many slope failures give off warning signs before they happen. Spotting these early can save lives. Cracks on the surface, especially near the top of a slope. Bulging at the bottom of a slope or retaining wall. Tilting or movement of fences, poles, or trees. Sudden changes in groundwater or surface drainage patterns. Geotechnical engineers conduct slope stability analysis to detect these risks. They use tools like inclinometers, piezometers, and aerial surveys to monitor slopes. Preventing slope failures. Prevention starts with proper design and site investigation. Engineers analyze the soil type, slope geometry, groundwater conditions, and loading patterns. To increase stability, they may implement slope flattening, reducing the steepness to make the slope more stable. Retaining walls, providing lateral support using concrete or stone walls. Soil nailing, inserting steel bars into the slope to hold it together. Drainage systems, installing horizontal drains, French drains, or surface channels to reduce water buildup. Vegetation, replanting trees and grass to enhance root binding and reduce erosion. Each site is unique, and a combination of techniques is often required. Real-world examples. Let's not forget the real-world consequences. The 2014 Oso landslide in Washington state killed 43 people. A combination of heavy rainfall, weak soil layers, and previous slope activity led to a massive collapse. In 1999, heavy rains triggered thousands of slope failures in Venezuela, killing over 30,000 people. These disasters remind us why geotechnical awareness and proper planning are critical. Final thoughts. Slope failures are more than natural accidents. They're the result of a complex interaction between geology, water, construction, and time. By understanding the causes and taking the right precautions, engineers can design safer roads, buildings, and communities. Thanks for watching. If you found this video helpful, give it a like and subscribe to Blueprint to Reality. We break down civil engineering topics in simple, engaging ways. Got a question or an experience with slope stability? Share it in the comments. Until next time, stay safe and build smart.